Hello, everyone. James from JTS Maths Tutoring here. Today, we are continuing with our examples of solving limits graphically or solving limits using a graph. So we have been given this graph here, or rather piecewise function, and they want us to answer this question based on this piecewise function here. So let's get started. Our very first question is asking us for the value of the function h of x at x is equal to -1. And this value is indicated by the field circle at coordinates -1 and 0. Therefore, the value of the function of h of x at x is equal to -1 is equal to 0. All right, let's go on to the second question. The second question is asking for the limit of h of x as x is approaching -1 from the right side. So x is approaching -1 from the right side. This is the piece of the function that we are going to look at, and we follow the orange arrow. And it can be seen from the graph that as x is approaching -1 from the right side, the graph or the function tends to or approaches 0. Right, we go on to the third question. The third question is asking us, what is the limit of h of x as x is approaching 0 from the left side? So what is the value of that limit as x is approaching 0 from the left side? We are still on this piece here. So we follow the light red arrow. And from the graph, it can be seen that the graph or the function tends to -1. The fourth question, what is the limit of h of x as x approaches 0 from the right side? So this is the piece that we are looking at here. And here we follow the purple arrow. And it can be seen from the graph or from the function that the function or the graph tends or approaches 0. The fifth question is asking us, what is the limit of h of x as x approaches 0? So for this limit here to exist, we check the limit from the left side of 0 and from the right side of 0. If those two are equal, then this limit exists. So we can see from 3 and 4 above that those two limits are not the same. Therefore, this limit here does not exist. Does not exist. Right, question number 6. Question number 6 is asking us, what is the value of the function of h of x at x is equals to 1? So we look here at the graph, and that value, we find it right here. It is actually indicated by this field circle at coordinates 1 and 1. Therefore, the value of h of x at x is equal to -1 is equal to 1. Right, we go on to the seventh question here. What is the limit of h of x? What is the limit of h of x as x approaches 0.5 from the left side? So where is 0.5? 0.5 is right here. So we make use of this black arrow, or rather we follow this black arrow, and it can be seen from the graph that the answer is 1. Then what is the limit of h of x as x approaches 0.5 from the right side. We are still on this piece here. So we make use of, or rather we follow this dark red arrow. And it's still giving us the very same value, which is 1. So now question 9 is asking, what is the limit of h of x as x approaches 0.5? So for this limit to exist, the limit from the left side and from the right side as x is approaching 0.5, it must be equal, of which we can see from 7 and 8 above that they are equal. Therefore, that limit is 1. All right. Now, the next question is asking us here, what is the limit of h of x as x is approaching 2 from the left side? From the left side. So we are looking at this piece here. So you can see that from the left side, the graph tends to 0. And what is thus the next question? Question 11. What is the limit of h of x if x is approaching 2 from the right side? So we make use of this green arrow here. We can see from there that it also tends to 0. Right. So that's number 12. What is the limit of h of x as x approaches 2? For it to exist, the limit from the left side and the limit from the right side of this function as x is approaching 2 must be equal. Therefore, the answer from 10 and 11 here, which is the sum, we get 0 here. All right. Now, right, they're asking us here, what is the type of discontinuity at x is equals to -1 and x is equals to 0? So at x is equals to 0, which is right here, we can see that these two graphs, they're actually separated here. And this is a jump discontinuity here. And at x is equals to 1, we have got a removable discontinuity. There is a removable discontinuity at x is equals to 1. Sorry, it's yes, that's it. And jump discontinuity at x is equals to 0. There we are. Thank you so much for tuning in. As usual, if you have any questions, please direct them to our Facebook page or Instagram page. Allow me to do what my mama taught me. A good visitor knows when to leave. Or she will say a good dancer knows when to leave the dance floor. Adios, amigo.